All right, we're going to talk a little bit more today about rational graphing. And there is an open-ended question on the quiz that says something like, I think yours is actually an error analysis question, but it says like, write a rational function that has an asymptote at 2, a vertical asymptote at 2, and a horizontal asymptote at y equals 0, okay? And you have to try to write one. So what we're going to do is practice this a little bit, and then we're going to look at some problems that are trickier than anything I would give you on a quiz, but it gives you an idea of this. So this is a warm-up you don't have, but it says something has a rational function has an x-intercept at x equals 0 and x equals 4. Okay, look at your reference sheet, your Peach reference sheet. If it has x-intercepts, where are those coming from? Where do you find x-intercepts when you have a rational function? In the top. So if we have one at 0 and one at 4, what are factors that are in the top? Plain old x, or x minus 0, right? And 4 means there's a factor of x minus 4, okay? Vertical asymptotes at 1 and 6. Where do you get vertical asymptotes from? The denominator. So what would go in the denominator? X minus 1 and x minus 6. Good job. Okay, horizontal asymptote at y equals 0. Now we're talking, look down at those choices. This problem you don't have anywhere. This is a warm-up, Maddie, but we're going to be doing actually 3A in a second, not 13. Sorry. The horizontal asymptote at y equals 0 happens when it is what? Okay, you need to be looking at the reference sheet, guys. Some of you don't even have it out. I'm speaking Greek to you here. When it is bottom heavy, it will have a horizontal asymptote at y equals 0. So is this bottom heavy right now? What's the degree of the top? If I FOIL that together, it has an x squared, and the denominator has an x squared. So it's not bottom heavy right now, right? What could I do to make it bottom heavy? I could put something else in the denominator. Like, if I put something that's also in the numerator, then I'd have a hole, right? So that's not going to work. But I could put in x plus 2. Now is it bottom heavy? Okay, it has an extra vertical asymptote, but it didn't ask us that, right? It just said it has to have at least. So you could do that. You could have squared one of those in the denominator to make it have an x cubed in the denominator. Something like that. All right, let's keep going. Is there one more of these? Okay, x-intercepts at 2 and negative 3. Whoa, I don't know what that is. Where do we need factors if it has x-intercepts or zeros, guys? Is that part of the numerator or the denominator? Numerator. So what are the two factors I need up here for 2 and negative 3 to work? X minus 2 and x plus 3. Okay, vertical asymptote at 4. Vertical asymptotes come from the denominator, and to be 4, it would have to have an x minus 4. Okay, a hole at negative 5, 0. A hole means there's what? Same factor top and bottom, and the x value is negative 5, so I have an x plus 5, x plus 5. Okay. For it to come out 0, we'd have to think about that a little bit. It means that when I put in a negative 5 in the reduced one, I get 0. Yeah, I'm not going to worry about that because I'm not going to make it that complicated. We're just going to keep going. All right. So this is question 1 on worksheet 3A. We are supposed to come up with the equation. This is complicated, okay? But I want you to see if you can help me with at least parts of it. Can anybody tell me one thing about this function, f of x equals? Where does it have a vertical asymptote, or where does it have a 0? A vertical asymptote at x equals 3. What does that mean? It means the denominator has a factor of what? X minus 3. Okay? We're going to talk more about that in a second. Where are the zeros? Can you tell where it's hitting the x-axis? -3 and 4. What does that mean? Factors of the numerator, right? X plus 3 for that -3 and x minus 4 for this +4 to be a 0. Now, what is it doing at those two places, guys? Both of those places, it's bouncing off the x-axis, right? Everybody with me? So both of these actually need to be squared. Okay, that idea is not on the quiz, but now, this is a new idea as well. Do you see where this asymptote is? On both sides of that asymptote, the end behaviors that are getting close to that asymptote are both going up, not one up and one down. So this denominator factor also gets squared. Then the last thing they'd like us to do is put in this ordered pair, 0, 24, to figure out what the stretch is. And I'm not going to ask you that on the quiz, so I'm going to go kind of quick. 24 would equal k times 0 plus 3 squared, 0 minus 4 squared over 0 minus 3 squared. This would be 9. This would be 9. This would be 16. What's 24 divided by 16, guys? That's 3 halves, maybe? Or 1.5 if we want to make it a decimal. So I'm going to put this in my calculator and see how we did. No guarantees we did it right. Okay, what did we have on top? Parenthesis. We had k was 1.5, and then we had an x plus 3 squared. Okay, is that it on the top? And x minus 4 squared. Okay, and all that was over x minus 3, times, is that it? That's it for the denominator? Okay. What was their window, guys? Going across, was it about -10 to 10? And going up and down? -25 to what? Okay, cross your fingers. Does that look like theirs? We are really good. We could try the y-intercept, and it comes out 0.24, which is the point we were wanting it to be at, okay? Let's try another one. Now, one more thing about this one. This is something you guys are still struggling with from the polynomials. What is the degree of the top, guys? This is an x squared times another x that's squared, right? So that's an x to the 4th up top. What is the degree of the denominator? X squared. Do you remember how to decide end behavior for a top heavy? You would have to divide. If I divided an x to the fourth by an x squared, I'd get an x squared. I don't know what exactly is going on, but an x squared shape is a parabola, right? Is the end behavior of this a parabola shape on the far outsides as it goes left and right? Okay, just trying to point that out. Okay. You would have, if you actually wanted to find the end behavior equation, you'd have to FOIL that all out and divide it by that all FOILed out. I'm just trying to get the idea that it's a degree 4 over a degree 2. So when you divided, you would end up with a degree 2 equation, which is a parabola shape. Okay. Yep. I definitely oversimplified how you would actually find it. Okay. So what can you tell me about this one, guys? There's a 0 at -3 and 2. There's a vertical asymptote, I would say, at -1 and over here at 4. So tell me something about that. Riley, tell me anything. X plus 1, good job. Also, what's in the denominator? X minus 4. What's in the numerator? Yep, to get that -3, we'd have an x plus 3. And also in the numerator, we'd have an x minus 2 to get this positive 2 right here. Now, did it bounce at -3 or at 2, or did it just cross? It just crossed. Okay. Now, on either side of -1 over here, where this asymptote is, 1/2 was going down and 1/2 was going up. Do you see that? So that means it's not squared. This one, same thing, down here, up on this side, not squared. We have one more hint. What is this? Horizontal asymptote. When do you get a horizontal asymptote? When it's either equal weight or bottom heavy. Bottom heavy has to approach y equals 0. Equal weight. So we need what? Equal weight, it approaches leading coefficient over leading coefficient. But are they equal weight right now? Do we get an x squared over an x squared, right? So can we just throw a 20 up top and that would be leading coefficient over leading coefficient? All right, how about, well, no, I can't see it once I start typing. I was gonna say someone could try. All right, let's just turn this one off, go to this one. Someone's gonna tell me what it says. It says I should just clear this. It's gonna be a hot mess otherwise. Okay, the top had a 20 and whoa, I forgot. That's a mess. X plus 3. That's not a 3, Hofbauer. And now what else? X. Dun, dun, divided by, what's the denominator have? So I need an extra parenthesis. X plus 1. Is the window close? Close enough, it should work. Does that look right? Okay, if I throw in the line y equals 20, looks about right. Okay. I'm going to stop checking them, but let's try one more. Do you want to do 3 or 4, guys? You want to try 4? All right, brave souls. Eek. I'm going to say this crosses at -6. Does that look close enough, guys? And +6. So where would those both go? No. They would both go in the numerator, right? Because they're where the zeros are. So an x plus 6 and an x minus 6, okay? And the vertical asymptotes are at -2 and +3. So that would be an x plus 2 and an x minus 3. Now, were either of the 6's bounces? No. Okay, and at this 2 asymptote, the left side was going down, to the right it was going up, yes? So we're not squared, but what happens at this 3 asymptote? Do you see how both sides are going up? That means that the 3 has a squared. Okay, so right now, what is the end behavior? What degree do I have? I have an x squared. Everybody's good there? This one is squared and multiplied by another x, so I have an x to the third. That's bottom heavy, right? And bottom heavy means it's approaching. Does that seem true? On the far left and far right, it seems to be staying very close to 0. I think we're okay. The only other thing you'd have to do is put in a 0 to get out a 40 somewhere. So you would have y equals 40 if there's some stretch and you're putting in a 0. And you will not have to do this. Okay, the top is -36, correct? Anybody checking me? Okay, the bottom, this would be 2 and this would become a +9, so that's 18. So 18 into this would be -2. And then if I divide the -2 over here, I get a -20. So we could check that as the leading coefficient that would make that work. Again, I'm just going to go on and talk about something else, okay, guys? Let's go back to worksheet 14B in the other packet. How much time do we have before I decide how much of this I'm going to do? Got 12 minutes still? Okay. I'm going to review cubic factoring. Write this down real quick. A cubed minus B cubed. Factor, this is the old packet. Is it almost the last page or the very last page? Almost, okay. And then does anybody remember how it goes when we factor cubics? Goes a squared, and at the back is b squared. Anybody remember the middle? A times a b. And then if it was a minus when we started, the first one stays the same. The second one is opposite and always positive. Does that sound familiar now? Okay, so what would this one be if we started with an a cubed plus b cubed? Anybody? A plus b, a squared minus ab plus b squared. Good job. Did you find the right worksheet, everybody? Okay, this worksheet says we don't have to actually graph anything, okay? Good news. I don't know about you guys, but I don't like drawing the graphs. We're supposed to find the vertical, horizontal, or oblique asymptotes or end behavior equation. So basically we got to do vertical asymptotes, holes, and then that bottom part about end behaviors. All we got is talk about. All right, so I am going to do problem number 3, and you need to write next to it. You're going to have to do number 5, which is very similar to this, okay? I'm going to factor. It factors x plus 5x plus 1. Whoa, whoa, that's not a 1. I can't blame the slate, right? Okay, the bottom, we have a 2x and a 5. Okay, that would give us a 5x and a 2x would give us the 7 in the middle. Okay, I think I'm good. So, what can you tell me? Any holes? Yes. -1. And once we write that down, that would also be part of the domain restriction. Okay, the domain cannot be -1 or what else? This one? -5/2. Everybody okay? 2x plus 5 equals 0 would mean x equals -5/2. So that would be the other domain restriction. We're going to need that number again in a second. But once you find the -1 and we reduce that off, now we put the -1 back in the reduced. Whoa. To find the whole, you put the -1 back in the reduced, which said -1 plus 5 over 2 times -1 plus 5. Okay, this is all that's left, is this piece after we reduce. So this becomes 4, -2 plus 5 is 3. Did I do that right? Anybody agreeing or disagreeing that we get 4/3? I think I did it right. All right. It asked for vertical asymptote. Where was that at? Yep, because that's the only thing that remains in the denominator after we take out the whole is that -5/2. And that's an equation, not an ordered pair. A few people did flip grids and I listened to them and they mentioned ordered pairs instead of equations. Asymptotes are always equations. Everybody know what I'm talking about? Either x equals for vertical or y equals for horizontal. Not ordered pairs. Okay, where am I going? End behavior. Anybody? The last chunk, top heavy, bottom heavy, equal weight. Equal weight. So then it is leading coefficient over leading coefficient. What's the leading coefficient of the top? 1. The leading coefficient of the bottom? 2. So it's y equals 1/2 for the horizontal asymptote, which is what our end behavior is for this one. It will get closer and closer to 1/2 as it goes far left or far right. All right, the next one I have is number 4, and this one is like number 6, okay? If you want to write yourself a note, you're going to have to do number 6 here in a minute. We need to factor the top. How do you factor x cubed plus 1? It is a cubic. What is the cube root of each of those? X plus 1. Okay, then we square the x. So we get an x squared. This is our a and this is our b. So when we multiply 1 times x, we get a 1x. We square the 1 at the back. 1 squared is 1. First sign stays the same. Second sign is opposite. Last sign is always positive. Okay, the denominator factors x minus 3 and x minus 2 to get a -5. Any holes? No holes, right? What? If you factored it differently? Okay. It'll only factor one way, and a cubic will never factor again. This x squared minus 1 minus plus 1, 1x plus 1 doesn't factor further unless there was something we could have taken out from the beginning. What about vertical asymptotes, guys? X equals what? 3 and x equals 2. It has 2 vertical asymptotes. All right, what about end behavior or horizontal asymptotes? This one is degree 3 over degree 2, so it is top heavy. What does it say to do for top heavy? Divide. Can we do synthetic division? No, we cannot do synthetic division, guys, so we got to do long division. But it's going to go quickly because we only have an x cubed up top plus 0x squared and 0x plus 1, and we get to ignore the remainder, so we're really only going to get one step out of this. What do we multiply an x squared by to get it to become an x cubed? Just an x, yes? If I distribute that x to all three of these over here, I get an x cubed minus 5x squared plus 6x. Okay, we have to go one more step, I think. Now if I subtract all that, this will become 0. This will become 5x squared minus 6x plus 1. Okay, x squared into 5x squared. What do we need to multiply by? So we get 5x squared minus 25x plus 30. Now, is our remainder going to be less power than an x squared? This is going to be a remainder because it's going to be smaller than an x squared, so I don't care about it. This is my equation. What do I write as my end behavior? It would be a slant asymptote, by the way, at y equals x plus 5. If I had more time, I'd keep going just to show you that it would be the remainder. All right, let me see. Yes. Is that my pen working wrong again? Thank you. All right, let me see if I have an assignment here for you before I run out of time. Well, all right, you have to check the lesson plan for the assignment.